It's raining tacos from out of the sky. Tacos, no need to ask why.
Why did I stop that banger of a song? Well, this is a physics project. You can listen to it on your own. Anyways, I'll start again in 3, 2, 1. Okay, continuing on. This physics project is about how some devices use waves. First, let's start with the introduction. This is the electromagnetic spectrum. This spectrum shows the type of electromagnetic radiation some devices use. The wave I am specifically talking about are gamma rays to be specific. Some devices that use and have gamma rays are nukes, radiation therapy, and smoke detectors. When I say smoke detectors, I mean that one thing in your house that constantly chirps if it's not clean and dusty. Yeah, that thing. And by the way, according to NASA, gamma rays have the smallest wavelength and the most energy in the electromagnetic spectrum. They are produced by the most energetic and radiated things in the galaxy and on Earth, such as areas around a black hole and lightning. However, the gamma rays in smoke detectors have a purpose, of course. There are two types of smoke detectors. The specific one I am talking about are ionization smoke detectors. In an ionization smoke detector lies a ionization chamber, which is a chamber that converts electrically neutral atoms or molecules to electrically charged atoms or molecules. So it basically just charges an atom or molecule. This chamber is essentially just two metal plates at different voltages, with one being positive and one a negative charge. The air molecules float between the plates until they are ionized by the radiation source americium-241. The negative and positive ions are then attracted to the positive and negative plates, resulting in a measurable constant current. However, if the air contains smoke, the smoke particles will stick to ions in the ionization chamber. The ions do not lose their electrical charges when this happens, but since the smoke particles are quite large compared to the ionized air molecules, the average mass of the charged particles in the ionization chamber increases. These particles are still in thermal equilibrium. We learned that term a few weeks ago, with the surrounding air, so that they must have the same average thermal energy. The amount of mass in the ionization chamber causes the average speed to slow down. This decrease in average speed shows up as a decrease in the measured current, which is what triggers the smoke detector's alarm. Americium-241 is primarily a alpha particle emitter, but it emits some gamma rays. It poses a more significant risk if ingested or inhaled, which is common sense. Once in the body, americium can stay for decades and continue to expose the surrounding tissues to radiation, increasing the risk of developing cancer. This is common sense to not eat radiation and things with radiation, unless it's a banana. Did you know that bananas have gamma rays too? Bananas have naturally high levels of potassium, and a small fraction of all potassium is radioactive. Each banana can emit 0.01 milligram of radiation. To put this to perspective, it takes away about 7.2 seconds of your life. However, for those who like to chomp on bananas, it is a very small amount of bananas, so don't go on a banana diet. To put that into context, you will need to eat about 100 bananas to receive the same amount of radiation exposure you get each day in the United States from natural radiation in the environment. Okay, this is my presentation. how smoke detectors use gamma rays to function and save lives. Actually, did you know that according to the National Fire Protection Agency, about more than one third, or 38% of fire home deaths result from not having a smoke detector to alert you of the fire in your house? This is why you should have at least one smoke detector in your house, because I care about you. Okay, thank you for listening to my presentation, and I'll see you next time. Bye.